a rock is thrown at the velocity of v naught at an angle a naught horizontal from the roof of a building of height h. So here's the building, height h, and instead it's thrown off the building with an angle of a naught, a velocity of v naught. Then it asks, calculate the speed of the rock just before it strikes the ground, and show that this speed is independent of a naught, or the angle it's forming. So first, we're going to calculate the speed of when it hits the ground. And to do that, we have to start out figuring out how fast it's going when it becomes level with the building, how fast it's going right here. And because air resistance is negligible in this problem, that means it's going to be a perfectly symmetric motion. So that would mean that the velocity when it comes to here is just going to be negative v naught. Now we need to calculate the speed when it hits the ground. And we can do that using our equation, because v final squared equals v initial squared plus 2 times the acceleration times the displacement. And if you want to take this a little bit further, final velocity is just equal to the initial velocity squared plus 2 times the acceleration of x, displacement of x. And so using this equation, we can easily find the speed when it hits the ground. And speed is the absolute value of velocity, so we have to keep that in mind. So now we're just going to plug in the values that are given to us here. So the initial velocity, when it starts right here, is negative v naught. So that means in our equation, it'll come out to be v naught squared, because the negative becomes positive because it's being squared, minus 2gh. And there's a minus there because the displacement here is negative h, because it's going down in the x direction, or down this direction. So it's going to be negative. So I have a negative h there, since the negative comes around. And then we have g, which is the acceleration due to gravity. And we take the absolute value of this, gives us our speed, which is the absolute value of the final velocity. So this is our speed when right before it hits the ground. Now the final part of the problem, it asks calculate the speed of the rocket before it strikes the ground and show that this speed is independent of the angle. So when you look right here, you can see that it is independent of the angle. The angle doesn't factor into this at all. If we want to be a bit more mathematical about this, we can look closely at it. So the equation to find the velocity of something is the square root of the x component of the velocity squared plus the y component of the velocity squared. So if you look at the components of this, so the x component will be, when looking at this triangle right here, the x component will be equal to v naught squared times sine